Aloha class, today we are focusing on area and volume questions that come up on the AP exam. And I'll be honest with you, these are kind of hit or miss. Some years, we'll see it like back-to-back years, and then they'll take like a 3 or 4 year hiatus, and then they'll work their way back into the AP exam. So, could we see it this year? Well, it was in 2019, okay? And then remember 2020 was the COVID-19. And so let's go over it just to make sure we're okay. But remember, anytime it's not as a free response, you will always see it as a multiple choice. All right, question 5, non-calculator. Remember, pause, see how you can do on your own. Okay, so we got two regions. We got a region G and we have a region H. And the interesting thing about this one is that it's non-calculator, and it doesn't say which one's where. And so one important thing to decide, even before I do any of these problems, is which one is on the top and which one is on the bottom. Well, I could put a 0 in for each of these guys. If I put a 0 in here, cosine of 0 would be 1. And so if I put a 0 in for this guy here, it will have the point 0, 1, which means the bottom guy is actually g of x. Some students got this wrong this particular year because they just assumed the first guy was the top one. AP, how about that? A little sneaky, right? The first one's actually the one on the bottom, and H is actually the one on top. So when it asks to find area, remember, that's very, very important. We're going to do the integral from 0 to 2. Now remember, when dealing with area, you can do top minus bottom as long as it always goes from H to G, and it does. So I'm going to want to do H of x minus G of x, dx. Now, non-calculator, a lot of work. And this can be tough for some of us, I know. So I'm going to take my time and do it with you. 6 minus 2 times the quantity x minus 1 squared minus negative 2 plus 3 cosine of pi over 2x dx. Okay, so what is the antiderivative of 6? Well, it's just 6x, right? What is the antiderivative of negative 2? Well, negative 2, remember, and we do want to save some time when we can, but this one right here, if I wanted to, it's like having a negative 2 out, x minus 1 squared, right, class? That's like a u squared. And if it's a u squared, it's kind of like a u sub, but you don't need to whenever remember, we said this many times in class, you don't ever, and you shouldn't be doing u sub, if when you take the derivative of your u, which is x minus 1, and the derivative of that is just 1, okay? You can just treat it as bring the negative 2 out, and then that would be u to the third over 3. But instead of u to the third over 3, it's x minus 1 to the third over 3, okay? And then here we go. We're going to subtract this stuff. Well, hopefully I'm not losing you here, but you have a negative and a negative, so that'd be a positive. And the antiderivative of a positive 2 would be a plus 2x, okay? And then that negative 3 goes. So once again, I'm going to come over here to the side, and it's going to be negative 3 that I'm going to bring outside, and then it'll be cosine of pi over 2x dx. Now, I know a lot of us would struggle with this guy, so I'm going to go over here just to not lose anybody. This time here, it's very interesting. Okay, some of us can handle it, some of us cannot. If I make my u pi over 2x, the derivative of this is not 1. It's actually pi over 2 dx, which, right, in class, we kind of do the reciprocal of that. And so if I were to simplify this, it would be actually negative 6 over pi, right, when I bring that out with the 3. And then it'd be the integral of cosine u du. And the antiderivative of cosine u would be actually sine u, with your u being pi over 2x. So that is actually the correct antiderivative. Now, remember, I already took care of this negative and this 3, so that would be 100% accurate there. And then it's a whole bunch of plug and chug, because I'm going to have to put a 0 and a 2. But fundamental theorem of calculus, now don't do all of that work and get it wrong. I plug the 2 in first, right? If I plug the 2 in, what do I get? I'm going to run out of room, I know it, but I get, here, we'll come up here, okay, you guys, and I'm going to get 12 minus, if I plug a 2 in there, 2 minus 1, 1 to the third, I get negative 2/3, okay? Plug a 2 in there, I get 4. Plug a 2 in here, I get pi, and sine of pi is 0, so it's minus 0. So I get all of that from the first half, but then I got to plug a 0 in for everything. Gone. So it's going to be 0. I'll take it one at a time because if I put a 0 in there, I get a 0 minus 1, which is negative 1. Negative 1 to the third is negative 1. 2 negatives make a positive, so it actually would be positive 2/3. And then I got to plug a 0 in there, I get 0, and then a 0 in there, and I get 0. So it looks like I get, what is this? 12 and a 4 gives me 16. You have a negative 2/3. You have another negative 2/3. So that'd be negative 4/3, right, class? And if I do all of that correctly with a common denominator, that'd be 3/48. So it'd be 44/3. Boy, that was a lot of work. Make sure you can practice it. That was worth 4 points. 4 points. One for the setup, one for each antiderivative, so that's 2 and 3, and then one for your final answer. So the AP was really testing here if you could do things the long way. How about that? All right, B. Region R is a base of a solid. For the okay, so this here we're going to be talking about volume, right? Because we got a base there. But now we're talking about cross sections that are perpendicular to the x-axis. And they give us what the area of one of those cross sections are, and they ask us to find volume. Remember when we did these in class. First thing we tried to decide is it dx or dy. Perpendicular to the x-axis would mean dx. Now remember, whenever we're doing cross sections, I made you go over here to the side and find the area of one of the cross sections. They give me the area of one of the cross sections. It's just 1 over x plus 3, and since it's dx, we're going to go from 0 to 2. But once again, you've got to find this by hand. Okay, well, how do I find it by hand? Well, that's 1 over something linear. Whenever it's 1 over something linear, remember, it's always a natural log of that something. Now, you just have to be careful, okay, right? This would be like a 1 over u, and if I did u sub, u would be x plus 3. Now, the derivative of x plus 3 is 1. So that means I don't really have to correct anything. I don't really have to use u sub, and that is the correct answer. We go from 0 to 2, and if I do that, I get the natural log of 5 minus the natural log of 3. Now, the AP would accept that as their final answer. Remember, if it was multiple choice, they probably would write the final answer like that. Do you need to go the extra mile on a free response? Heavens, heavens, no. But we all know for multiple choice, they like doing it. Okay, right. But do not evaluate. Make sure I have students every year. They end up just evaluating it because you get in a groove. But if it says do not evaluate, please don't do it. Okay, we're going to give the volume of the solid when rotating it about y equals 6. So if I rotate it about y equals 6, right, I get this crazy shape up here, right? Boom. Okay, there's my crazy shape. And if I rotate it about that, that's going to be a dx problem, right, class? And then hopefully you realize, okay, hopefully you realize that this is 100% a washer. Why is it a washer? Because these regions are not attached. They are not attached. And whenever it's a washer problem, right, that's capital R squared minus a little r squared. Don't you forget what I almost forgot. And it would be a pi right there. It's a dx problem, which means we go from 0 to 2. So if I can find capital R and I can find the little r, I'm donezo. Remember, how do I find capital R? Well, capital R goes from the end to the end, the two ends. And then that would be the diameter. All we have to do is find the radius. And make sure you always use it in your initial picture, your original picture. And my original picture goes from 6 down to the curve. Remember, that curve was g of x. So it's going to be 6 minus g of x. Okay, and then what's the little guy? Well, the little guy, remember, goes inside to inside. It's going to be the hollow part, the washer part that you cut out. And once again, that's the diameter, so the radius would be from the line down to the curve. And remember, that was h of x, so it would be 6 minus h of x. And just make sure you guys put it all together. Darn it, I almost forgot the pi again. Don't forget it, you'll lose a point. And it's 6 minus g of x squared. And yes, class, you are correct. You do not have to write out the entire function. If they define what those guys are from the beginning, you can use that in your answers. Right? And that was worth 3 points, believe it or not, if you were able to get that all correct. All right. Area volume, it was in 2019. You guys guess Guess which test I had to go to find another area volume on a free response? I had to go all the way to 2015. So let me change my page here, and it's number 2, which means it would be calculator, which means they weren't expecting you to do all the work. They worried more on this one about setups. All right, here we go. Number 2, we got these crazy curves. And we're allowed to use a calculator, so immediately you should plug that in y1 and that in y2. And the first question they asked me is to find the sum of the areas of R and S together. Now, why are they asking me R and S? Why did they break it up? Well, guess why? Very, very interesting here. Okay, very, very interesting here. But these two graphs intersect. And the very interesting thing about it is that the top and the bottom kind of flip-flop. All right, if you're very careful here, you see that this right here is actually g of x. Once again, it comes second. This guy down here is actually, whoops, f of x. Okay, and you could graph those to figure it out this time. It's not like you magically would have to know that. However, now they obviously give you the endpoints, 0, 2, 2, 4, but we need to know that. So you guys graph these, make sure you can do it. Let's find that intersection point. Okay, hopefully you graphed it and you found out that the intersection point was at 1.032832. And remember, you better remember how to store that in alpha A, okay? And then the y value would be 2.401108. And what you want to do when you're going to find something that intersects, you might use this throughout the test. You're going to say, let A equal that, and then you're going to say, let B equal that. And you want to write that in your booklet because when you write it, you can use it. That's the awesome thing. Just like I can use f of x and I can use g of x, okay? So how am I going to find the area? Well, area is just top minus bottom or right minus left. Well, I can do top minus bottom until I get to that point of intersection. So my area sum would be the integral from 0 to a, right, because it's x's, because I did vertical rectangles, okay, which would be g of x minus f of x. And all I would have to do is math 9 that with my y2 minus y1. But I'm going to add to that from a to what? X equals 2. Make sure it's x's, right, because it's still top minus bottom. But this time it flip-flops, and it's going to be f of x minus g of x. Now practice plugging that in your calculator, okay, using your y1, y2s, but this is what you would put in your booklet. And if you do that correctly, I get 2.004 as my answer, and that would be worth 4 points, okay? Now I know I went through that rather quickly because I'm not typing it all into my calculator. But you guys, do not go on to the next video, next problem, next part until you've tried that in your calculator on your own. All right, region S. So we're just focusing on this region right now, okay? It says we have cross sections that are that are perpendicular to the x-axis that are squares. Find the volume. Okay, I was talking about this right in 2019. How do we find the volume with cross sections? It's V. The volume is equal to the integral of A. It's perpendicular to the x-axis, so it'd be the area of one of the cross sections. And it'd be dx, once again, perpendicular to the x-axis, and I'm going to go from 0 to 2. This is the one that I taught you side work, right? Remember, in 2019, they just gave it to us. Here I got to work a little bit. And then what did I make you do? I made you draw a two-dimensional cross-section, which happens to be a square. Then I had you write down what is the formula for the area of a square. It's just side squared. That's it, just side squared. Okay, so if I know what a side of one of these squares is, I'm good to go. But guess what? I do know what it is. Remember, let me label these correctly here. The one on top here is actually f of x. The one on the bottom is g of x. Class, does it make sense that a side of this square is just top minus bottom, which would be just f of x minus g of x? So that's the area. I mean, that's the area of any one of those squares. And why do I have the x's in there? Because it's going to vary. And you know what's awesome about this problem, you guys, is that I get to use my calculator. So in my booklet, I'm going to type this out. I'm going to write it out exactly the way that looks like. Oh no, boo, boo. It's just the red area. Almost made a mistake. So this is going to be alpha A. This is going to be alpha A. Then I'm going to type that bad boy into my calculator, and I get an answer of 1.283. And that got you 3 points. So how about it? Let's get area on this one. That's already 7 out of 9. Now, I almost made a boo-boo, so just make sure you're really careful. Obviously, that point of intersection was really, really important. All right, C's got to be tough, right? Let H be the vertical distance between the graphs. Okay, so that means H is equal to F minus G. Okay, so H is the vertical distance in S, and we're still just focusing on S. Okay, find the rate at which H changes with respect to X when X equals 1 point. What? Rate of change? Rate just means derivative. So I just got to do H prime of X equals F prime of X minus G prime of X. And then don't I just have to plug in a 1.8? And this was supposed to be the tough one. Come on, AP, hook us up. Put one like this on our AP exam this year. And if you get that answer, you get negative 3.812 or negative 3.8 ichi 11, depending on if you round or truncate. But remember, always do final answers to 3 decimals. You may round or you may truncate. All right, that was 2019 to 2015. Skipped 4 years in between area volume questions. Let's see when it comes next. 2014. So maybe it's going to come up this year. Let me get my answer key ready to go. All right, here we go. Let's say you did a great job on the first 2 we did. Come on, challenge yourself, you guys. Do this one on your own. Okay, we got R. It's a region enclosed. So just one region now. It is number 2, so that means, again, I calculator. So let's be really good at setting stuff up. Okay, but it's the region bounded by that quartic polynomial in the horizontal line y equals 4. Find the volume of the region R if it's rotated about y equals negative 2. Ooh, y equals negative 2. That's way down here, right? That's way down here, and it's going to be rotated this way, which means I should know that it's going to be a dx problem. The other thing that I should know is that it's going to kind of, and I know I'm not going to be the best at drawing these guys, that's it, but this is, whoa, I drew that way wrong. Come on, Mr. T, that's why I'm not an architect, you guys. But it would be kind of like, this would be there, and then it would be like down there, boom. That's a little bit better of a drawing, okay? And so this is definitely going to be a washer problem, which is capital R squared minus little r squared. It says this is y equals 4. If it's dx, I'm going to go from x equals 0 to x equals what? I need to know where they intersect. Well, let's find out where they intersect. And they intersect at 2.3. Now, how do I find that? Plug that in y1, plug that in y2, figure it out right now. And where they intersect. Now, since my answer key is 2.3, it must be a pretty answer, but you should let A equals 2.3, right? Store that in your alpha A, put it in your booklet so you can use it. Boom, I'm going to use A right there, or 2.3. And then I do what I almost always forget to do, but then I always remember, it's pi r squared, right? All right, so if we find capital R and we find little r, I'm donezo. Capital R would go from the end to the end. And remember, that's the diameter. The radius, and you've got to use the original picture you had, would go from negative 2, would go top minus bottom. So it would be 4 minus negative 2, which would be 6. So the big radius is always going to be 6. The little one is actually going to go from curve to curve. And it will go from the curve, because this is where it's drawn, and we would do top minus bottom, remember. The diameter is from the curve to this curve, but the radius would be from the curve to negative 2, which would be f of x, minus negative 2, which would be f of x plus 2. So my final setup would be pi from 0 to a of 6 squared minus f of x plus 2 squared dx. And if you plug all of that stuff into your calculator correctly, you get 98.686 or 98.687, depending if you round or truncate. And yes, you could have left the pi out there and just given the decimal for the integral part, and you still would have got full credit. That was worth 4 points. So that was worth a ton. Boy, If they go back-to-back years, it's 2019, then we had COVID, so maybe it's going to come up this year. That'd be pretty awesome because I think you guys would dominate some area volume type questions. All right, part B. Region R is a base of a solid. For this solid, each cross-section perpendicular to the x-axis is an isosceles right triangle, and I have to find the volume. So this is a cross-section problem, so it's V equals. Whenever it's a cross-section problem, I need the area of one of those cross-sections. Now, those are x's because it said perpendicular to the x-axis. So once again, I'm going to go to 0 to 2.3 or alpha A. All right, now what did I tell you to do? I taught you to go over here to the side. And when you go over here to the side, I asked you to draw your two-dimensional picture. Boom, isosceles right triangle. Now, what's the important thing about an isosceles triangle? Well, that's just 1/2 base times height. But guess what? Ding, ding. In an isosceles right triangle, the base and the height are the same. So all I have to do is find what does B represent in my picture. And if I were to draw one of these guys, it like jets off the page. I'm not an architect, but you have all of these isosceles right triangles and they jump off that page. But guess what a side is? It's just top minus bottom. So a side is simply 4 minus f of x. That's it. So if I come over here now, I'm going to bring the 1/2 on the outside from 0 to a, and it doesn't really matter. You wouldn't have had to bring it on the outside. You definitely would have wanted to if you had to do it by hand. But this one, you don't have to do by hand. And if you do it correctly in your calculator, you get 3.574 or 3.573, depending if you round or truncate. That's worth 3. So just like the one before you guys, man, that's 7 out of 9. Whew, I'd be getting a 5 on this bad boy if we had problems like this, right, you guys? Make sure you hit pause and try the last one on your own because it is the tough one. Okay, we have a vertical line. X equals 5. Boom. Whoa, what? Okay, we got a vertical line, x equals 5. And it's going to split this region in half. X equals k. It's going to split that right, but do not evaluate an expression involving integral expressions whose solution gives the value of k. All right, so I'm going to split it up, and I got to get my answer, and it's got to be equal to. But how do you feel about this? It's just area. It's not value. So why don't we just top minus bottom, top minus bottom, top minus bottom, top minus bottom, and say the integral from 0 to k of top minus bottom, which is 4 minus f of x, has to be equal to the integral from k to, what was it, 2.3 or alpha a, right, 2.3 of the same exact, because it's still top minus bottom. Wouldn't that get it for me? And guess what? You don't even have to do anything by hand. Come on, that was supposed to be the tough one. Let's go. Nice and easy, Japanese. I got a 9 out of 9, you guys. I got one more area problem to do with you guys. Come on. What a great study little method right now. If you do this next one entirely on your own, and it's number 5, so it's great. It's going to be non-calculator. So what's the AP going to do? They're going to make sure I can do some busy work. So go ahead and get it started right now. All right, here we go, you guys. I really hope you try this on your own. Let's get after it. Find the area. Area is top minus bottom, right minus left. I don't know about you guys, but every one we've done has been top minus bottom, right? It doesn't get broken up. But be careful. Make sure you remember how to do right minus left. If it's right minus left, remember everything has to be wise. Everything has to be wise. But everyone we've done so far, right, is top minus bottom. Maybe they want to make it easier for you. All right, you need to know what those guys look like. Hopefully you know that this guy down here is f of x because it's parabolic. And cosine goes down first, so that'd be g of x. So they would expect you to know how to do that. Now, I don't have to find intersection points because they beautifully kind of give it to me there. So how would I find area? Well, area would simply be equal to the top minus bottom, but I'm going to have to do a lot of work here. And it's dx, top minus bottom, so it's going to be from 0 to 2 because they all have to be x's, but then top, and I'm going to have to write it out here because I'm going to have to do work. So it's 4 cosine. And you guys, I really hope you're trying this one on your own because this is the second one we're doing kind of like this. Minus f of x would be 2x squared minus 6x plus 4. Sorry, I'm running out of space, dx. All right, let's do some antiderivatives. All right, I would bring the 4 on the outside, right? So it'd be 4 integral cosine. I got to do this antiderivative. Remember, we've already talked about this. Okay, this would be like a u sub, where your u would be pi over 4x, which means my du would be pi over 4 dx, which means dx is equal to 4 over pi du. Okay, so I'm going to substitute here, right? I'm going to bring the 4 over pi out here with the 4, which gives me 16 over pi. And then I'm going to rewrite this as just cosine u du. And the antiderivative of cosine u is just sine u, but I'm going to plug the u back in, and then I'm donezo, and I beautifully have the antiderivative. So I was going to say bring that 4 out, but I just did all of the work. So it'd be 16 over pi sine pi over 4, or 1/4 pi, right? Same thing, x. Okay, and then I'm going to distribute that negative, and if I do the power rule, I'm going to get 2x to the third over 3, right? If I distribute that negative, it's going to be positive, and I'm going to get 3x squared, right? These are just power rules, and then the last guy was a 4, that'd be 4x, and then I just have to make sure I evaluate it from 0 to 2. Okay, let's plug the 2 in there. If I plug a 2 in here, I get 16 over pi. If I plug a 2 in there, I get sine of pi over 2, which is ichiban, or 1. Okay, I plug a 2 in there, I get negative 8. Whoa, not negative 8. I do get an 8, but times 2, so that'd be 16 thirds. Plus, plug a 2 in there, 4, I get 12. Plug a 2 in there, I get 8. And then if I plug zeros in, only one I have to be careful about is this first one. Sine of 0 is 0. So everything turns into a 0. So you just got to do really that work, which would be 16 over pi minus 16 over 3 plus 20. And believe it or not, the AP would probably give you full credit if you got it, but that shouldn't be too tough to translate. Ooh, did I make a boo? Let me see here. Did I forget something, you guys? I feel like maybe I made a sign mistake. Ooh, and I did make a sign mistake. I was looking at the solutions. Distribute that negative. That should be a negative, which would make that a negative, which would make that a 4. Now that's easy to combine because that's 12 over 3, so I get 16 over pi minus 4 thirds. Booyah, that would be worth 4 points. So, I got a little bit lackadaisical with that negative sign. So what's that teach you? Be careful, especially on these ones that are non-calculator. They want you to do all that work. Now, believe it or not, I just would have lost 1 out of the 4 points, but I don't want to lose any of those points if this type of problem were to come up on the AP exam. All right, the last 2 are right but do not evaluate. An integral expression that gives a volume if we rotate it about y equals 4. Y equals 4, right? This is very similar to kind of 2 of them we did already. This is going to be a washer. And it's a dx again, right? Because we're rotating it about y equals 4. It's perpendicular to the x-axis. So I'm going to go from 0 to 2, but it's capital R squared minus little r squared. What's capital R? Let's draw it. From the end to the end, remember, that's the diameter. Top minus bottom gives us the radius, which would be 4 minus, what did we say that was? That was the parabola. Okay, little r goes from the inside to the inside, remember. That'd be the diameter, so the radius would be top minus bottom, which would be 4 minus g of x. So my final setup would be, shame on me. See, I told you I almost always forget that pi. Don't forget it. Okay, it would be 4 minus. And make sure you're good with your parentheses and your organization. If you forget a parentheses or organize incorrectly, you will be penalized, all right? That's the answer right there. And you can keep that as an f of x and a g of x. And if I did that correctly, that would be 3 points, and I would be 7 of 7. All right, last one to go here in terms of area and volume. All right, what's it say here? It says, right, but we have cross sections that are squares. Cross sections that are squares. So now what have I taught you about cross sections that are squares? Well, I told you it's the volume is equal to, it'd be the integral of the area of one of those cross sections. Now, since it's perpendicular to the x-axis, these would be x's, this would be from 0 to 2. Go over here to side work, right? Draw yourself a two-dimensional object. Since it's a square, the area of a square is just side squared. I just need to know what a side is. And a side's just top minus bottom. So it's just g of x minus f of x, right? But make sure you square it. So we get the integral from 0 to 2. I can't believe they don't even make us do the work here. But you know what? You do so much work in that first one that they're not going to make you do the work. Now, the one thing that sometimes we get in the bad habit is we put a pi in front of everything, right? Especially if it's volume. Incorrect. Pi only if you revolve. Okay, these are cross sections that are squares, so there's no way I would put a pi. You have to plug that in your calculator. No, you do not. That's done. So that'd be 2 more 9ers out of 9ers if you were able to get that all correct. You guys make sure, maybe look up, see if you can find one. I'm very surprised. Everyone we did today, right? We did with regards to x's. I've seen them on old AP exams where they do it in terms of y's. So look it up, get better at these. I'll see you in class. Allahaz.